last talk for this session. Yeah, due to last minute scheduling change, is going to be remote. So I'm going to introduce Matthew Bailey. And I
Yeah,
think you can share your screen and we should be able to see it.
yeah. Hi, everyone. Thanks. Sorry, I was originally intended to attend in person there, but I ended up throwing my back out there just at the last minute. So hopefully everyone can see this and hear me okay. But yeah, so my talk is building an R package, R Shiny application in Quarto book for cumulative effects assessment in BC. So just a quick overview here, putting together a large R project and just using this CEMPRA application as a case study of an R project and our Shiny application. And then kind of thinking about the theme of the talk here is how can we sort of apply principles of software development within the R universe, such as separation and concern, modularity, and so on. I'm going to kind of highlight some useful workflows here, and then briefly at the end, if there's time, talk about some novel and special tools. So my background, I work as a quantitative biologist with streams, rivers, salmon, and so on. I've been using R for about 14 years, and I also do quite a lot of web development in other languages too. So I kind of wanted to give that sort of perspective of how the whole Shiny thing and the R universe maps on to the external world there. I'm really passionate about reusable tools, systems, and frameworks to support environmental management. So why do we even worry about organizational structures and systems in R2? And I put this diagram together here, and I think a lot that this might resonate with a lot of the participants here, at least at some phase in your R career and journey, where you invest so much time into a project, and then you have this initial boost at the beginning of product gains and productivity and functionality. And then eventually you keep putting more and more time in it, but it just becomes so complex to build and maintain that the progress starts to kind of peter out and asymptote there. The other kind of example of this is where we're forced to revisit an older project or an older code base for a revision, and there's just that dread of trying to figure out how everything fits together too, and what's going on there. And so some of the questions I always kind of ask is do all large software projects follow this trajectory? They all become messy and complex? Sometimes this seems to happen more in R rather than others too, and trying to think about why that is. Kind of think about the R learning ladder and pathway too. So as sort of others have mentioned here, we kind of get introduced to R. We're doing lots of data analysis in Excel or whatever, and then we move to R scripting, start thinking about dynamic variables, for loops, functions, and so on. And we kind of get to this point where we're proficient in R, but it's sort of just enough to kind of get jobs done in isolation too. And then usually that's at some point, we go to use R in grad school or in a job too. And then eventually we sort of move on to other things. We go from working in isolation to working in others. And then from working on always new greenfield projects to more brownfield older projects too. And then that's when it really becomes important to adopt practices for collaboration and code adaptability. And then just kind of thinking about why this is so important is that R's surged in popularity over the last 15 years. Almost everyone coming out of any specialized grad program is proficient in it. It brings people together. However, some of the larger projects still sort of struggle with structure and maintainability. And I don't think the answer is just imposing new frameworks or other complexities on other people, but instead sort of encouraging structures that you can kind of build on for maintainability and scalability. And then also, I think this is really important because if you're at this conference and sitting in the audience today here, you're probably one of the individuals in your organization that can lead the charge in this. So I wanted to introduce a project I worked on recently called CEMPRA. It's a cumulative effect modeling application. It's developed as an R package and R Shiny application. And one of the key components about this project is it was developed in collaboration with numerous different individuals across different organizations too. I'm not gonna go and spend too much time on the nuts and bolts of the application or what it is, but I want to kind of talk about more about the framework under the hood. So, but just briefly, it's a cumulative effect risk calculator. There's a life cycle modeling component with stressor response relationships. And the Shiny app itself has all sorts of different components to it to review and edit data, to like click and select, deselect spatial data, to change layers, to run scenarios, and for file management and so on. It's also got a whole bunch of population ecology, like mathematical models in it too, just to kind of throw that into the mix too. So the project layout, one of the things I think what's really important is when building a Shiny application is this kind of concept of separation of concern too. So I interpret this in the Shiny universe as sort of thinking about if you have like a bunch of core code and function, which is the biology or the math or the core data processing, I always like to put all that stuff in an R package, and that kind of separates all like the complex data processing too, and then you're not thinking about reactivity at all in the R package. It's just plain old vanilla R and functions. And then kind of separating the whole Shiny application is the realm that deals with all the reactivity, object management, user interface, and so forth too. And this sort of separation of concern makes it so like all the folks who are interested in more of the web development reactivity and the folks who are into the hardcore math can continue to edit and maintain the project without having to cross that domain if they don't want to. Then what this looks like in practice is the R package is composed of a bunch of discrete R functions. So your core R functions, each one of those just kind of following this single responsibility principle. It's got documentation. It's nice and clean and clear in what it does. And then the our Shiny application is composed of different modules too. And so this is kind of like within each of those two categories, we have these two different sort of subcomponents, and this is how we achieve single responsibility and then modularity. And then talking about some key things to look out for in the R package component, and then what we kind of have to do to build and kick this off is usually you're going to come like when these types of projects are born or evolve too, you're often starting with a lot of different R projects from different individuals in your organization or other organizations too. And there is sort of a little bit of manual work of kind of moving code maybe that other people have written that are separated across different projects, and then trying to kind of, if you're trying to make a reusable tool, putting that into standardized R functions there, and then sort of moving that into the R package structure. Within an R package, if you're building one for the first time, I really like this R Oxygen 2 tool, which is just uses these @ tags for each of the components in the documentation. If you've never built an R package before, there's lots of great resources online, including this book, to help. But really, just to demystify it, all an R package is it's just a folder with a bunch of R functions, some tests, which are optional, but I'll get into later. And then this inst folder, which just has all miscellaneous CSV data files that are embedded into the package. Building the R package itself is just a product of adding functions in, loading them, documenting them, and then installing the package too. So there's really elegant ways to make an R package that it'll get published on CRAN and everything will be really perfect. But also, like, you can start just by having a folder of R files and R functions there, and not worrying about all the nitty-gritty bits of it in the beginning. One of the key things I really recommend for anyone following this framework is actually making use of the tests, not so much maybe on the Shiny side at first, but definitely within the R package side. So tests, the idea of tests is that you edit or update a function and you run these tests, and the tests sort of look like individual scripts where they run out a bunch of different scenarios. So you can try sample functions, and then you're looking for expected values. So if I import a data set where one parameter is low and another parameter is high, and then I think the scoring system is going to give me a different type of result. You run these tests and they're just these static R scripts, and then there's these expect true components to it. And so I can see in this package that it's covered by like 900 and something different tests too that we created over time. And these tests give us pretty high confidence that that if we go to change and edit the anything else in the package over time, that we're actually quite confident that it won't result in any breaking changes. I didn't used to use tests in R, but now I could never live without them too. And then they, in the R universe, offer the key kind of debugging and error checking too. Moving on to the Shiny application, just we've seen a lot for the modules from Erica's talk and the other fellow there too. So I'm just going to kind of go through this section a bit briefly here, but just thinking about the whole Shiny application component of the project is that it's stripped away from any of the core functions or population biology or other things too, but it's more of just the web interactivity. And similar to the previous talks too, so separating out the Shiny application into modules too, otherwise it just becomes a nightmare to maintain. So if you don't use modules, you can build it, but then you can never really look at it again or figure out anything. And as your apps get more and more complex, modules get more and more important. So this is sort of just an example of our Shiny application here, which the file structure itself looks a lot like the R package file structure, but then just in this R folder here, we have all our different modules. Not going to go into too much detail, but the module is just the R file where each module you separate your R code and your server code. I liked on Erica's talk too, where she showed an image of her app too, and then highlighted all the different places where there's individual Shiny modules. So just looking at this app on the surface, this is what it looks like. And then each of these boxes here is a separate Shiny module. So each colored box is a different module. Some of the modules are just appear once on the page, but some of them appear multiple times. So each of the modules, in this case, in the red box, these are being reused and auto-generated and auto-updated too. When you make use of the Shiny modules, you turn, like, I think each of the module scripts in this apps are only about 300 to 500 lines long too. So each of them just functions as a miniature app, and it's quite easy to understand and maintain. If you're just using the vanilla R Shiny application, you're not using a larger framework too. There's some other sort of utility functions here that also live in modules, but there's no UI component. It's just the server component. So some of this involves like defining the reactive values, setting them up for each session, and so on. And just kind of thinking back here to other web frameworks such as Angular, Vue, .NET, PHP, Drupal, etc. They all sort of use common themes of services, templates, modules, etc. And all of these are sort of equivalent to variations of Shiny modules too. So this whole kind of framework and pattern is something that gets repeated all over the software development universe. So in our project is like when we're thinking about the layout in comparison to core software development principles, just showcasing this setup that I really like to use, where you have your R package, your R Shiny application is two separate things. The R package is loaded in to the Shiny application. Each of these are made up of carefully organized R functions, unique Shiny modules. This way you can keep using the R package in offline analyses without having to copy and paste code out of a Shiny app. So this could be useful for the Shiny app for non-web programmers or using just the package in isolation. When we think of the core software development principles, we get separation of concern here, single responsibility principle. We have modularity, maintainability, because all the different scripts and components are quite small, scalability, reusability, and then if you're using tests, parallel testing in development there. And so why even worry about structures and systems in R? And so when you adopt these setups and frameworks, we get to moving from projects where they have this asymptotic growth to them to something that you can keep growing off into the future. I'm just going to skip this part here for time, but take-home messages. Large R projects don't all have to be overly complex, and leveraging R packages and Shiny app modules can give a clean organizational framework for long-term growth of nice, steady, reusable projects. And great, thanks for the opportunity to present here.